Riddle me this, mother lecker.
A square with a side length of 5 is positioned with its corner in the center of a square with a side length of 4 as shown in the diagram. One side of the overlapping region between the two squares is equal to 3. The puzzle is to calculate the area of the overlap between the two squares. That is, to calculate the area of the red shape. I thank Ohad from Israel for suggesting this problem. Can you figure it out? Give this problem a try, and when you're ready keep watching the video for a solution. So, how can we figure this problem out? Well, the first thing is the sign of 3 is actually irrelevant to this problem. We'll remove it. Next we'll draw blue lines to extend the sides of the square as shown. What does this do? Notice the square with a side length of 4 is now divided into 4 identical shapes, each with an area equal to the red shape. Therefore, each shape is equal to 1/4 of the square's area. So the red region has an area equal to the area of the square, which is 4 times 4, or 4 squared, and then we divide it by 4. This will be equal to 4. Amazing. In fact, we can extend this problem that the area of overlap between the two squares always has an area of 4, so we consider a square with a side length of 4 and then we have a square with a side length of 5. What we'll do is we'll create a tiling where we have 4 different squares with a side length of 5. Notice the square with a side of 4 is divided into 4 identical shapes right now, each with an area equal to 4. Now this will be true even as we rotate the squares with a side length of 5. We still have the square with the side length of 4 being divided into 4 identical shapes each with an area equal to 4. Now we can continue the symmetry as we rotate the larger squares. The square with a side length of 4 is always divided into 4 different identical shapes. Therefore each will have an area that's 1/4 the area of the square. It's a pretty neat problem, and rotational symmetry solves this like magic. Did you figure it out?
Riddle me this, mother lecker.